Okay, folks, so I'm actually just using Geogebra to draw an orthographic projection for you, but what you're seeing right now in front of you is actually a rectangular prism that I would like you to attempt to draw either on paper or on Geogebra. Okay, so I'm using Geogebra because I want to show you the front, top, and right hand side view based on quadrants. And you'll be able to see why it is very important to space those drawings out based on a 45-degree projection line. Okay, so let me just quickly move this off to the side, and then what we'll do is we'll just quickly identify a couple of key features that we need to know. So first and foremost, we need to know that we are actually looking at 2 units across for the front view in terms of the width. The height is 3 units up, and the overall length of the base there is 5 units in length. Okay, so 2 by 5 times 3. Okay, now I'm going to start at -2 here, -2. So what you'll find is I'm drawing the front view here on the negative quadrant, and I'm going to draw the top view as I project the front view up onto the positive quadrant. And then, of course, I'm going to be projecting it towards the right on the positive and negative quadrant for the right-hand side view. Okay, so let's begin drawing the front view. And I'm just going to get the line there. And it is 2 units across, as we can see here. So I'm going to start with -2, just because it's nice and even, and there's going to be a beautiful 45-degree projection here as indicated by my line. So we've got -2, and then of course if we're looking at 2 units across, that will end up being -4. Now the height is 3, okay, so we've got the height there at 3. So then we go -2 to 5. So this is going to be an approximation. It's not 100% perfect, it's not clicking to grid, but it's going to give us a representation of the front view. So would you say this is representative of that? Now I could change the names here so that it's easier for you to understand mathematically. I can do that now if you like. However, I'm going to just label this as front view for now because that is good practice. So let's go front and always uppercase, because that is AS 1100s for uppercase when we do labeling. Front view, okay. Let me do it. Oh no, that's right, wrong one. Text. Front view. There we go. So we've got your front view there. Now I'm going to use projection lines just to project it up, but I'm going to make it even. So I'm going to make it even in that I'm going to go 2 units up. So if that's 2 units difference there, I'm going to go 2 units up this way. Okay, so I'm going to get that line again. Where is it? There it is. Okay, so I'm going to use that. I'm going to start here. And as you can see, if I project a line, just a rough line up, okay? And then if I project a line across, I'm going to try to replicate D and E, okay? There we go. That should project beautifully up that way as well. Now we know that this is 5 units, so we know that one is also 5 units because that's also parallel, which means that is 5, that is 5, okay? So let's bring it up 5 units, which means that if I go 5, that would make it up to 7 there. 7, and okay, so that's a little bit rough, my drawing. I'm going to have to redo that and get a little bit more accuracy. Clearly, I did not zoom in, which I should have. I want you folks to get nice and accurate, okay? And I'm just going to quickly select the line view, okay? And then I'm going to go move it up and zoom out. There we go. That's a little bit better. So if I go there to there, that snaps on, and there we have it. We have a perfect rectangle, which is the top view, and I'm actually going to delete these projection lines, okay? In reality, when you create projection lines, the projection lines are going to be lighter in line, okay? So you're going to generally use 2H, 4H, and 6H pencils, which we have in class, okay? So when we get back, we'll identify and determine exactly what we need to use for projection lines. And in this instance, obviously, we're doing this on Geogebra, so it's not really giving us a really great example of what it would be like if we were drawing it in real life by hand, but at least this is something. Now, I'm going to draw the right-hand side view, but before I do that, I'm going to create a 45-degree projection line, okay? So that should cut across right through to all of these points, because that is a perfect 45 degree, right? Yes, because that's a square, okay? And we're cutting or bisecting that, and we are getting a 45-degree line. Now, as you can see, that projects and that hits that particular point, which means if I project this across here, then it's going to intercept from there and from there to this point, okay? And I know that that is actually going to project out this way. So I'm just going to quickly zoom in, and I'm going to try to get it to snap to 5, okay? And then I'm going to know that, hey, that's 5 across because we're drawing this right-hand side, okay? And therefore we're going to go from 2 to 7, snap that. And you can see that if we bring this up and if we bring this across, that is going to hit this particular point on that bisector, okay? Which means that's going to perfectly snap on, look at that, perfectly snap on to that point. Okay, so I'm just going to get out of that. I'm just going to draw that as an example. And then let's do the other lines. Okay, so I'm going to zoom in, and then I'm going to now draw it there, and then draw that baseline. Okay, so I'm just going to quickly snap all these together, just so that you've got a good understanding as to what these projections are designed to do. Check it out. Look at that. I'm going to label these now as front, top, right-hand side view. And where is it? There we go. So that will be top view. And this one here will be right side view. You can say right-hand side, but it's a bit too long. Stick to right side view or right view. Some people like saying right side view because they're going to draw a left side view, but right view is fine. Okay? Now, have a look at this. This is true orthographic projection with a 45-degree projection line. We've got this perfect lineup of the projection lines from the top view all the way down to the right-hand side view. And if you backtrack the whole process, you'll see that we started off with the front view, projected it up towards the top view, then we drew the top view, completed that, then we projected it across onto the 45-degree projection line, and then projected it down towards the right-hand side view, which also allowed us to project the front view off to the right-hand side. So I'm going to delete these lines, okay, those points, and you can see there, this is a perfect third angle orthographic projection of this rectangular prism. Now, I know it's very simple, but I want you guys to try to get this perfectly on either a sheet of paper at home, or you could use Geogebra. If you do use these ways of implementing your drawings, especially if you're familiar with Geogebra, I'm sure you would have used it in maths at some point, please take a snapshot of what you've done, okay, and post it on OneNote. I would like to see that you have done some of these activities so that when we get back to class, I know you guys will be all over it, okay, and we can move on. Yes? Wonderful. Okay, so folks, email me if you have any questions about this task. Okay, bye folks.